So what we're seeing in this table here is as the pressure on the gas in a balloon changes, the volume of the gas changes. So as X increases, or as pressure increases, Y, or the volume, decreases. So what we're being asked to do here is find the inverse variation function and use it to find the resulting volume when the pressure's at 30 pounds per inch squared. So what would be the resulting volume here? So the first thing I need to do is find the inverse variation function. And the way I'm going to set this up here is I'm going to set it up so that I can find y. I want to isolate y. So if I were to look up at the equation above here, if I were to isolate y, well, I'd divide both sides by x, and I would end up with y is isolated, and y would be equal to k over x. And this is the equation, or the formula, I'm going to use to solve for y. And remember, pressure we're going to think of as x, volume we're going to think of as y, and that's going to give me this resulting value below. So the first thing I need to do is find that inverse variation function. And in order to do that, all I really need to do is find k. And there's a couple of ways to figure this out or find it. I want to just move this equation over a little bit to the left, right about there. So in order to find out what k is in this equation, well, all I really have to do is solve for the product of x and y. So let's go ahead and solve for the product of, in fact, I don't think that's going to show up that well. So we'll just know that I'm going to take 5 and multiply by 300, which will give me a value of 1500. And if I were to do the same thing with any of these xy values, so if I were to multiply 10 times, I'm going to fix that multiplication symbol there. So 10 times 150, 10 times 150 will also give me 1500. And 15 times 100, 15 times 100. This will give me 1500. And finally 20 times 75, 20 times 75 is also equal to 1500. Okay, so this tells me that the constant's going to be 1500. So my function here, or my function over here, would be, in fact, I'm going to change back to the blue real quick. Y is equal to 1500 over x. So let's take this information. All right, so I'm going to take this information and I'm just going to copy it. And I'm going to move it over to the other side of the screen, just so I have another one to play with here. Okay, so now I'm going to take 30 and substitute it in for x in this equation. So now I have y, it's equal to 1500 over 30 here. Okay, so 1500 divided by 30 is going to give me a value of 50. So y is equal to 50. And I'm going to get back that purple. And I'm going to plug 50 in right here. So we have 50 in here. That's our final answer. Now I want to show you something cool here. So in this problem, we were actually asked to find the inverse variation function and use this function here, or this formula here, to solve for the unknown value, or to solve for the volume when the pressure is at 30 pounds per inch squared here. Or another way of saying that is actually 30 pounds per square inch. Okay, so now what I want to do here is just think, what if I wasn't asked to find a formula to help me solve for my missing value? Would there be another way of solving this problem? All you have to do is look at the scale. What's the scale changing by to get from one number to another? So in this first case, well, how did I get from 5 to 10? Well, to get from 5 to 10, I had to change my, or scale up by multiplying by 2. And I would do the same thing here, kind of, but it's the inverse. It's inversely proportional. So the scale is going to, it's not going to scale up. It's actually going to scale 300 down. I'm going to divide by 2 here. So I'm dividing, and that should be a division sign. So let's actually fix that. So a division sign, and I'm going to do that one more time. Let's hope that it comes out this time. So 300 divided by 2 will get me to 150. So I could do this for any of the values here. And an easy one to do here is to look at the scale of changing from 15 all the way to 30. Well, what would that scale be? In fact, I want to fix that arrow real quick. So my scale here, Again, I would scale up by multiplying by 2. I'd scale up by 2, which means I would scale 100 down by 2, and I would divide 100 by 2 here to get to 50. And that's just another way of solving for this problem. Cool stuff. I'll see you in another video.